So one of the questions that you might get in the exam is regarding plate boundaries, and one of the ones that you need to know is a divergent plate boundary. So you can see here that I've already drawn the diagram for it, which obviously whenever we're talking about a feature in geography, I would always advise you draw a diagram. You can get a couple of different types of questions. The most common one is the one that I've written there, which is describe or explain how they're formed. And in those questions, always draw the diagram like I've drawn here. You could, especially in the foundation paper, be given an image such as the one there, or kind of one from a textbook type image, and be asked what type of plate boundary it is, and you'd need to tick to know which one it is. Either way, you've got to know the process that they're formed by. So you can see here that a divergent plate boundary is essentially two tectonic plates moving apart from each other, and you can see that the picture down at the bottom, if I just highlight for you, the one that I'm talking about is down here. The most famous close to us is the Mid-Atlantic Ridge, because we in the UK are here, and you can see that Iceland is directly sat on top of it, and that's actually because the divergent plate boundary has created Iceland. The magma has rised up through the mantle and escaped from the gap as the two tectonic plates move apart, and if that builds up enough and actually breaks through the surface of the sea, then an island is created, and that's exactly what's happened in Iceland. So if I got this question at the top, so if it says describe or explain how they're formed, so what would we write? So we'd write something along the lines of convection currents in the mantle pull the plates apart, and I've drawn those convection currents here, so I'll draw it in just a different colour, you can see, and the convection currents are coming up from the mantle and pulling these plates apart. And then we kind of try and discuss what happens then. A gap, and if you can use it, the term fissure is really good. I've labelled it on the diagram and it's down there on the explanation, is created, leaving a space for the magma from the mantle to rise up, and it fills it. If that happens to start with at the bottom of the ocean, as the magma actually hits the water, it cools it very sort of quickly, and as I say, starts building up the island. We discussed Iceland earlier on. A volcano is created, often beneath the ocean, as I've just said. A new sea floor or the ocean floor is created from that. And then because of this, as the magma rises up and the fissure touches the water, it solidifies or hardens. Now, as it says on the top tip here, you quite often get taught that there aren't any earthquakes on these boundaries. There are sometimes, because whenever a crust is moving apart from each other, you can get some sort of movement which creates earthquakes, but they're usually very small compared to the other plate boundaries that we'll be looking at. So it's mainly, this is a sort of a volcanic boundary, but you can get some small earthquakes.